Good evening, everyone. Welcome to the homework portal. And today we'll be starting with the new set of problems on electricity. Well, I was not available for a month. The reason is because my net connection was not proper and lots of work. And okay, so anyway, we have begun with the chapter on electricity in the school. Let us begin with this now. Okay, so now just a minute. Right. Okay. Right. Just give me a moment. Right. That's open. Now, the question it has put forward here is, let me put off my video because it's not showing me a clarity here. Right. Okay. An electron enters the region between two charged plates initially moving parallel to the plates. Okay. The electromagnetic force acting on the electron. Now, when you say these are charged plates, so now the field lines would be like this. Would be like this. If suppose, if this is a parallel plate capacitor, then this could be positive. And if this is positive and if this is negative, or vice versa, anyway here, then the electric field line would be like this. The field line would be like this over here. Right. Now, electromagnetic force, how will the force act on the electron? This electron will now be deviated like this, which means now the force acting on it is the electron is now getting pulled in this direction. So causes the electron to decrease its horizontal speed? No. Causes the electron to increase its horizontal speed? No. Why? Because it is neither opposing the electron in this direction, nor it is aiding the electron in this direction. It's parallel to the field lines and is the opposite direction to them? Yes. It's parallel to the field lines. The force is now parallel to the field lines and is in opposite to it, which means what? The electron is grabbed by the positive plate. So therefore, this should be your right answer. It's perpendicular to the field direction. The C is the right answer. Okay, now let us move on to the next one. An ion of charges Q plus Q vertically moves through a small distance S in a uniform electric field. So this is my uniform electric field. Now it starts from here and moves to this point. The distance between them is S. That's what is given. The electric field has a strength E. It's given as E. What is the electric potential difference between the initial and the final positions of the ion? What is the potential difference across these 2 points? That's the question. Now, we know that dV by dr is equal to E, right? Now, what do we need? Potential difference. dV should be equal to E times dr. Now, what is dr? dr is nothing but S. So, therefore, this should be E times S. So, the answer here is C. Okay, let me move on to the next one. Two wires X and Y are made out of the same material. Okay, then the wires are connected in series. So let us say this is my X, this is my Y, this is my Y. Then the radius of X is twice that of Y. Oh my God, X is thicker than Y. Okay, I'll draw a thicker line over here. So X is thicker than Y. This is the radius of X, so X is thicker than Y over here. Right. The carrier drift speed in X is Vx and Vy. Now, before that, the wires are connected in series. What does it tell you? That means if I am connecting a battery here, then what will happen? If they are connected in series, the same electric current flows through both the wires. Okay, same electric current is flowing. So, which means Ix is equal to Iy. Right. The wires are connected in series. Radius of X is known. Okay, the carrier drift speed in X, Vx versus Vy. So he's asking you the ratio of the drift velocities. Now we know that Ix is equal to NEA VD, right? So this is a formula which we have already seen. So N is the number of electrons or number of charges per unit volume, which is constant for a given material. See, this metal, same metal, which means N is same. Okay, I will write Nx is equal to Ny. E is electronic charge. What is area? Area is nothing but pi r x square. And this is nothing but pi r y square. And what is Vd? Vd we do not know. Let us say Vx and Vy. And Ix is equal to Iy. Ix is equal to Iy. So we need to find Vx by Vy. So how do I do? Since Ix equal to Iy, what do I do now? I'll write Nx, Nx, E, Ax, Vx should be equal to Ny, E, Ay, Vy. Now this charge and this charge goes away. Since Nx is equal to Ny, so I cancel this also. Thus we get Vx by Vy is equal to Ay divided by Ax. Now what is Ay? Ay is pi Ry square. Pi Ry square divided by pi Rx square. Now what is Ry and Rx? Rx is twice that of the Ry, right? That's what is being given over there. It tells you radius of x is twice that of y. So therefore, I'll just write pi and pi gets cancels away here. I'll write this as Ry radius of x is twice that of y. So this should be 2 times that of Ry. 2 times that of Ry. So which should be equal to 1 by 4. Because Vx by Vy equal to 1 by 4. The right answer here is 0.25. Right. Next. Electrons each with the charge E move with the speed V along a metal wire. Okay. The electron current, the electric current in the wire is, what is the electric current in the wire? Is I, okay, sorry, plane P is perpendicular to the wire. How many electrons pass through the plane P in each second? How many electrons in every second? Which means what is the unit? Number of electrons per second. This is what it is. What do you call this as? N. What do you still call this as? Electron density. This is nothing but number of electrons per unit time. Now we know that I is equal to Ne divided by T, right? E by T is nothing but the current due to one electron. If there are N electrons, I can just write this as Ne by T. So what do we need here? We just need the value of N over here. Now, not N, we need the value of, I'll group this as N by T multiplied by E. What is N here? Number of electrons. T is in 1 second. So N by T into E or N by T is equal to I divided by E. Thus the answer is answer D. Okay. Lastly, a positive charge is uniformly distributed on a semicircular rod. What is the direction of electric field center at point S? So if you look at these directions, now you see positive charge distributed. So this is the positive charge over here. This is the positive charge. Uniformly distributed on semicircular plastic rod. Okay. What's the direction of the electric field center? Now what will happen is each one of them will now try to repel. Will now try to give right to an electric field line like this over here. If you look at the field lines like A, D, and C, all of them are pointing towards the plastic rod, which is incorrect. Which is the right answer? Answer B. Thus, B is the right option, which means the net electric field strength at point S would be directed outwards. Okay, fine. So with this, I think we have come to an end to the 5 MCQs that we have put across. If you have done it well, be happy. Thank you, friends, for watching this. And let us see with the next video from tomorrow. Thank you. If you really like this videos, do like, share, and subscribe to my channel for more updates. Thank you.